Welcome to youtharea 2.0 air channel. Today we are going to discuss about current electricity for class 10. As per previous lecture, we discussed about current electricity up to Ohm's law, that means V equal to IR. Now we are going to discuss about the type of material on the basis of resistivity. The resistivity, which is outcomes of Ohm's law, and it is known as intrinsic property of any material which opposes the flow of charge or flow of current through any material. It means the types of materials are classified on the basis of resistivity. There are three types of material known as conductor, insulator, and semiconductor. First, conductor. The resistivity lies between 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter. It means very low resistivity. That is, the number of free electrons are too much. There are a great number of free electrons. Second one, insulator. The resistivity 10 to the power 10 ohm meter to 10 to the power 70 ohm meter means maximum hurdle, maximum resistivity means few or no free electrons. Third one is semiconductor. The resistivity 10 to the power minus 5 ohm meter to 10 to the power 2 ohm meter. It means free electrons, number of free electrons lies between the number of free electrons for conductor and insulator. The property of semiconductor, simply the property of semiconductor lies between those of conductor and insulator. सिंपली कोई भी प्रॉपर्टी जो सेमीकंडक्टर की हो वो लाई करेगी जो कंडक्टर और इंसुलेटर की प्रॉपर्टी होगी उसके बीच में. दिस सिंपली द टाइप्स ऑफ द क्लासिफिकेशन ऑफ मटेरियल ऑन द बेसिस ऑफ resistivity. The special type of material known as superconductor. This is beyond the syllabus of class 10 but very interesting, that's why we are discussing here. What is superconductor? Those material which resistivity becomes zero at below a certain temperature. As per our knowledge, we know when free electrons are moving through any material, then due to thermal agitations, resistivity and resistance shows their effects. But when we are talking about a particular temperature or below this particular temperature, then resistivity of this material becomes zero. It means the flow of current is very small and very fast for a very long time, up to which we maintain this particular temperature or below this particular temperature known as critical temperature. Very interesting. This particular temperature is known as critical temperature. Critical temperature. That's all about the types of materials on the basis of resistivity. As you know, the theme of this lecture session, the content, the syllabus, the very important topic regarding to your examinations are carry on our finger. That means we are going to settle the topics and most important content for examination point of view in our mind. Very simple, because at the last night of examinations we are very in hodgepodge conditions, means we think about which topic is more important and how can we cover a lot of content in a single night. After a very good mode of study, we are going little bit in hodgepodge conditions. But when we carry our topics and syllabus at our finger, that means we settle them in our mental saturation point. And in this way, we are very soothing mood for examinations. And revision is very interesting in a single night without any hodgepodge condition. This is the theme of session, and in this lecture, part B of current electricity for class 10th, in our first finger, the types of material on the basis of resistivity. Now we are moving on our second finger, effect of current electricity. There are three effects again. First, chemical effect. Second, magnetic effect. And third one is heating effect, which is also known as Joule's law of heating effect. Chemical effect of electric current is beyond the syllabus for class 10th or class 12th also. Magnetic effect of electric current theoretically means qualitatively available in the syllabus of class 12th, and also a brief view, a narrow view of magnetic effect of electric current also in class 10th syllabus. But heating effect is available in detailed mode, Joule's law of heating effect, in class 10th syllabus. That's why we are going to study about heating effect in the section of effect of current electricity. Heating effect of electric current. When we apply a potential difference through any conductor, then we know that the random motion of electrons are aligned in a particular direction. The internal resistance of this conductor is assumed as R, and the potential difference of battery is V, and the amount of electric current flowing through them is I. Then what's the situations when we are talking about heating effect of electric current? That means Joule's law of heating effect. It means simply due to the resistance, due to the resistivity, due to the intrinsic property of the conductor, this conductor, amount of heat is generated. According to Joule, the amount of heat which generated due to this condition means applying a cell or battery which potential difference is V and flowing amount of current is I, and the resistance of this particular conductor is R. H is directly proportional to I square. H is directly proportional to R. H is directly proportional to time up to which electric current flowing through this conductor. Means simply Joules say that A change directly proportional to I square RT. And when we remove the sign of proportionality, we get H equal to I square RT. This is known as Joule's law of heating effect. Joule's law of heating effect means simply the first statement is the amount of heat is directly proportional to a square of electric current passing through the conductor, passing through the appliance or conductor. The second statement is the amount of heat is directly proportional to resistance of the appliance. Third statement is the amount of current is directly proportional to time up to which the current passes through the appliance. Simply, when you find the questions in examinations state about Joule's law of heating effect, then first of all you have to write down on these three statements regarding Joule's law of heating effect, and on the basis of these three statements we represent these statements in mathematical format like that, and after that we conclude in a single line is directly proportional to I square RT, and that's why after converting proportionality sign into terms of equality, Joules gave proportionality constant is unity. That means the value of proportionality constant is 1. That's why we get H equal to I square RT. That's all about Joules law of heating effect. But our point of view, there is missing of V. That's not a big plus because we are very smoothly connected with Ohm's law. We have H equal to I square RT, and we think that we convert this mathematical representation in terms of potential difference. It's very simple. We have to think about R and we have to think about I also. We know that D equal to I. That's why I equal to V by R. And in this way, we put this value and convert this mathematical formula in another form. This form is especially in a new topic known as electric energy. What is the electric energy? The amount of work done through a complete circuit following current electricity through them. Simply, when current electricity flowing through a closed circuit, then the amount of work done for completing a circle of current electricity is defined as electric current. Very simple. We know that I equal to Q by T. It means Q equal to IT. Nothing is worried about here. Now, potential difference V equal to W by Q. It means W equal to VQ. In this two mathematical representation, W equal to V and Q equal to IT means W equal to VIT. Here we get a formula W equal to VIT. That means the amount of work done when I electric current flowing through a circuit after applying a potential difference of V up to time T. We think about how can we convert this formula, because here heat energy means amount of work done, and on is also here W equal to I square R2, I equal to V by R, V square by R square, RT, V square by R means W equal to V square by R into T. This is the three ways to represent the amount of work done or the amount of heat which is generated through by any appliance when electric current flowing through them up to a particular time T, and the particular condition Vi and R. This all about our second topic regarding effect of current electricity. Electrical iron, heater, a lot of electrical appliance which works on the basis of heating effects of current electricity. In initial stage, when we are talking about heating effect of electrical current electricity, then we think that this effect is very harmful in terms of energy. But when we make a lot of appliances which work on the concept of heating effect of electrical energy, then nowadays we are in very profitable conditions in terms of energy, because we doing a lot of works on the basis of on the applications of these appliances which works on the basis of heating effect of electric current. The third topic is electric power. Basically, according to me, I simply says that if you are thinking about physics, then you have to think about natural phenomenon. In our very first session, physics means the study of natural phenomenon. How can we study a natural phenomenon? I simply say that you have to think about the factors which affects any natural phenomena in terms of physical quantity. I very frequently says that the 30% or more than 30% of the syllabus of physics is directly related to physical quantity in terms of examination point of means. If you remember and if you are ability to connect physical quantity with natural phenomenon, that means you have a tendency to build up a mathematical representation. And what is the beyond this line which I am saying just before? Nothing. Means you have to completely focus on physical quantity. Got it? The rate of dissipation of electrical energy per unit time is defined as, or what is power? The amount of work done per unit time. Simply, this is the definition of power. But when we are talking about electric power, then we are saying that the rate at which electrical energy is dissipated, because electrical energy converted into heat energy according to our syllabus, or when electrical energy converted into heat energy, it means the loss of electrical energy, dissipation simply. So the rate of dissipation of electrical energy is defined as electric power. Here W equal to VIT in previous mathematical derivation. That's why P equal to VIT by T. T terminated each other. That means P equal to VA. This is the very popular formula for electric power. A lot of formula in terms of resistance and electric current, in terms of resistance and electric current, in terms of resistance and potential difference. When we replace I in terms of V and R, you get a formula in terms of V and R for electric power. A lot of formula. Basically, I am trying to say you that when you get a numerical questions in your examination, then no need to hoss and no need to think about a particular formula. You have an ability to collaborate the topics in interdisciplinary exam. I hope you understand better. This is the third point known as electrical power, third finger. Now we move on our fourth topic known as commercial unit. Just before the fourth topic, what is the power of electric power? Simply what is the SI unit for power? Other big unit is kilowatt. Now the fourth and according to syllabus the last topic, commercial unit of electric power. Means the meter, the electric meter in your house read the dissipation of electrical energy in a month in which unit, known as commercial unit. When an appliance work or use 1 kilowatt power up to 1 hour, means an appliance which power for dissipation of electrical energy is 1 kilowatt, and this appliance is used up to 1 hour, then what happen? Then amount of heat energy is 1 kilowatt hour, means 1000 watt into 3600 second. 1000 watt means watt joule per second into 3600 second. I hope watt is converted in terms of joule per second, because power work by time, work means SI unit joule or time means SI unit second. This is the SI unit of power, which is known as watt. Then here second terminated, that means 365 times 0 joule. When we represent in terms of scientific unit, scientific denotation, 3.6 into 1 2 3 4 5 and 6, yes, 6 joule. This is the amount of work, this is the amount of heat energy, this is the amount of electrical energy which is used by a house, and on the basis of this value we calculate amount for a month. This is a commercial unit of electric power, kilowatt hour. And what is the value of 1 kilowatt hour in terms of joule? This is 3.6 into 10 to the power 6 joule. An objective questions regarding this terminology. Horsepower. Horsepower means 1 HP, 7 86 watt. Basically, you think, you listen, not think, you listen that the motor of 1 HP, half HP, 2 HP. Basically, HP horsepower is the capacity for dissipation of electrical energy in terms of any other form of energy. And the value of horsepower is 786 watt. That's all about the chapter current electricity for class 10th on your fingertips. Today we only use 4 fingers for remaining our current electricity for class 10. First finger carry the types of materials, means conductor, insulator, semiconductor, superconductor. The second one finger means simply related to the heating effect of electric current, applications, practical applications. And the third finger directly related to electric power, electrical energy. And the fourth finger is related to commercial unit. That's all about the session. Thank you for watching. Please subscribe and like. When you watch the lecture, you need to pause them when you think that you have to write down and prepare notes. Thank you for watching. Tata. Bye bye.